Folks, welcome to Statistics. What's up, folks? Welcome to the next lecture of Statistics. What's up, folks? Welcome back to Statistics. Today we're going to be talking about binomial geometric normal models. Maybe not all, but definitely some. Alright, so let's check out today's problem. Here's today's problem. 91% of emails are spam. You found that 151 of 1422 emails are junk. What's the probability that no more than 151 of 1422 emails are real? Alright, so let's break it down. What is this question asking? Well, apparently some company, maybe Gmail or Google, tells you that 91% of emails, whoops, sorry about that, tells you that 91% of emails are spam. Alright, so some random company tells you that, and it's a pretty famous company, so you kind of believe them. And by the way, my email is full of Chipotle and Grubhub and all that stuff. So yeah, I'm pretty sure this is real. And you go ahead and maybe you want to verify, you check and you find that 151 of 1422 emails are junk. So the question is, what's the probability that no more than 151 of 1422 emails is real? Okay, so that's the question we're being asked. And in this case, how do you even start answering this type of question? That's the key. Look at the type of question you're being asked. In this case, we're being asked for a certain amount of successes out of a certain amount of trials. Basically, we're being asked the following question. What's the probability? The probability you'll have this many successes out of this many trials. All right? So what's the probability that something like this would ever happen? Right? That's the question you're being asked. Well, to answer these kind of questions, remember, we like binomial models. They're kind of built to answer these type of questions. But to even use a binomial model, remember, we need to check whether the trials themselves conform to Bernoulli trials. It's easy to kind of mix up Bernoulli and binomial, but try not to get them mixed up. So, Bernoulli trials, what are they? Well, they conform to the following three laws. Number one, your trials must have either two outcomes, success or failure. Success here means a real email. A failure here means a spam email. Bernoulli trials also have to keep probability of success constant, which in this case is 9%. Since spam happens 91% of the time, since spam happens 91% of the time, real emails will happen the other 9% of the time. Alright, the final clue to a Bernoulli trial is that the trials are independent. So if one email is spam, the other one is not influenced to be spam. It's not like they're buddies or emails can talk to each other. Alright, now with that being said, how do we start answering this question? Well, when you have such a large number of trials, 1422, and you're being asked a kind of interval-like question that no more than 151 emails are real, it's really hard to answer that question using binomial models, because then you have to answer the question for 151 successes, 150, 149, all of that. Instead of saying no more than, it said exactly 151 emails out of 1422 are real, then we could use binomial models. Then it would just be a simple calculation of the following, right? All we have to do is take our number of successes, which would be, I don't know, what was it, 151? Yeah, our number of successes, 151, we would choose our number of successes out of 1422 trials, and then we just multiply that by the probability of success, 0.09, times the probability of failure. And of course, we'd like to raise these guys to their respective powers, 0.09 happening 151 times, 0.91 happening 1422 minus 151 times, all right? So if the question had instead asked exactly what the probability of exactly 121 successes occurring is, then we could use binomial. But since it's asking a kind of interval-like question, no more than, that gives us a clue that we want to kind of, use normal models, not binomials. So how do we use a normal model for this? Well, remember, a normal model tells us the following. The normal model tells us the expected value of, a continuous random probability distribution like this is NP. And of course, being the total number of emails you're looking at, and that in our case is 1422, and multiplied by your probability of success, which in our case is 9%. Our teacher likes to write the 0 before the decimal, so why don't we write that? So that being said, 1422 times 0.09, go to our calculator, there it is. Let's try to calculate 1422 times 0.09, oh whoops, and that gives us 127.98, as you can hopefully see. So let's go ahead and write that down, 127.98. That's our expected value. How about our standard deviation? Remember, standard deviation is just as important to constructing the normal model. Well, it's exactly the same calculation. It's the probability of your success times the number of trials you have, but this time we're going to multiply it by the complement of the success, aka the probability of failure, and take the root of that. And so what is that going to be? Well, we already know NP, that's 127.98 times Q. Q is the probability of failure, which in our case is 0.91 or 91%. And now I can go back to the calculator and actually calculate what this is, multiply this by 0.91, and then we can take the square root of this. So if you take the square root of this on our calculator, what are we going to end up with? Well, it should be around 10.79, which is our final standard deviation. So let's go ahead and write that down. That's our standard deviation, 10.79. And now we have enough to construct a normal model. We have both our expected value and our standard deviation. So let's go ahead and construct a normal model. So what's our normal model going to look like? Well, we're going to have a mean and a standard deviation. So what's our mean going to be? Well, our mean, remember, let's zoom back out. What was our mean? Our mean was 127.98. So let's zoom back in. Let's write that down as our expected value, our mean, 127.98. What's our standard deviation? Our standard deviation, of course, is going to be 10.98, if I remember correctly. 10.79 rather, 10.79. So that means our data values, one standard deviations away from the mean, are going to be what? Well, they're going to be basically 10 bigger than this. So let me go back to my calculator and add 127.98 to this so we can figure out what our data values, one standard deviation away, will be. And it's going to be 138.71. 138.71 at one standard deviation away from the mean, and maybe one standard deviation below the mean, it'll be 117.18. Now, with that being said, we have our whole normal model. We can answer our original question. What was our original question? It was asking whether 151 out of 1422 emails is real. No more than. So really what we want to do is find the following probability. We want to find the following probability that we want to find the probability that 151 out of no more than, so that means less than or equal to 151 out of 1422 emails are real. And so let's try to find what this is equal to, right? What is 151 out of 1422? Well, we don't even have to do that, right? We can just find where 151 is over here. We can find where 151 is in this normal distribution. 151, let's just guesstimate it's maybe around here, and we want to find the probability. What does this graph show? Remember, what does this show? Does this show the failures or the successes? Well, remember, since we multiplied by the successes, this graph really shows us all the successes here. Okay, so we really want to find out all the data values less than this. We want to find all this humongous area. How can we find what this area below 151 is? How can we find that area? Well, whenever you're tasked with finding the area in a normal distribution, what should you think about? You should think about the z-score, right? Z-score is what makes standard deviations and normal distributions work. So let's go ahead and find the z-score of 151 here. I remember the z-score formula. Hopefully you remember that the z-score is given by your data value minus your mean over your standard deviation. What's our data value 151. What's our mean? 127.98. What's our standard deviation? It's gonna be 10.79. 10.79. And so now let's go back to our calculator. Maybe I can check out what this is gonna equal in terms of a z-score. So I want to calculate 151. So let's get rid of all of this. Can we clear all of this? Hopefully we can. And now I can just plug in 151 minus 127.98, and that's going to be this random number divided by 10.79. That's going to give us 2.134 standard deviations away from the mean. 2.134 standard deviations away from the mean. And now let me check if I wrote that correctly. 2.1334. 2.1334. If we round to the nearest 10,000, we'll get 2.1335, and that is the z-score. But now we have to find the actual area, the probability associated with that z-score. How do we find the probability associated with a z-score of 2.1335? Well, of course, we can just use the z-score table. So let's go to Google and let's find the z-score table. And look, there it is. So let's look at 2.1335. So 2.1335 is going to be where? Let's see if I can highlight this thing. So 2.1335, so that's going to be 2.1 is along here. 2.13 would be along here. And so what do you end up with? What data value do you end up with? I'm afraid that's a bit too large, but hopefully you can see what that is. It's 0.9834. It's 0.89834. So with that in mind, what's our final probability? Well, our final probability is as follows. The probability that no more than 151 of your emails. What is our final answer? Well, if you look at 2.134, our final answer is 98.34. And so that is our answer, folks. 98.34%. Your spam filter and you are working correctly to identify spam. Thanks for watching this lecture. We'll check you out next.
Embedded plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO, and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.